Okay, folks, in this lecture we're going to take a look at three different types of unit conversion problems. Changing the prefixes, units of area and volume, and then looking at rates of change. So, in all problems you'll be given the conversion factors, or in some cases you would be expected to know them. Say 1 hour is 3,600 seconds. That'll be one you'd be expected to know. So we'll take a look at the first problem type, changing prefixes. So I kind of decided I'd go through an example first and then give you the kind of method at the end once you'd seen a couple of examples worked through. So we're asked to change from milliliters to microliters. So first thing, guys, is ignore that number until the very last step. We want to kind of establish the base relationship. 1 milliliter is how many microliters? That's all our work. And then bringing the 1.6 in is a very last and simple step. So don't bring that 1.6 in at the start, or you will make, now it's certainly possible to arrive at an answer, but it will make your life a good bit more difficult. So first thing we need to figure out, guys, is, well, what's the difference in powers between milli and micro? And we're looking for the absolute difference in power. So that means with no minus signs. So here's milli, here's micro. The difference in powers, guys, is 10 to the power of 3. So that's our absolute difference in powers. Now, this is very important, guys. The next thing we want to figure out, well, is what way are we going? Are we going down the list? Are we going from bigger values down to smaller values? Or are we going up the list from small to big? In this case, we're going from big to small because we're going down the list, milli to micro. And as a result, guys, you multiply by the difference in powers. So this becomes our conversion factor. So like I said, 1 milliliter is 1 by 10 to the power of 3 microliters. So that's our conversion factor. And that's what we were looking for all the time. And finally now, it's quite easy, multiply both sides by 1.6. Like I said, this just comes in at the very end. And we get 1.6 milliliters is 1,600 microliters. And notice as well, guys, every line I've written makes sense on its own. So we look at another example. Convert 240 centimeters to meters. Now again, if you do a bit of building or anything like that, you'll be able to do that in your head. But we'll take a look because there's just a few things I want to point out in this as well. So establish the base relationship. We want to go from centimeters to meters. 1 centimeter is how many meters? So what's the difference in powers? And there's a few different ways of doing this, guys, but I just like this method because it applies kind of universally regardless of what units we're changing. Well, the difference in powers now, guys, is we're going from centi just up to meters. So there's no prefix on meters. There's no prefix, so that means we're at 10 to the power of 0. It's the unit value. The difference in powers is 10 to the power of 2. And in this case, guys, like I said, we're going up the list. So we're going from a smaller value to a bigger value. Centimeters to meters, small to big. And because we're going up the list, guys, we multiply by the reciprocal of the difference in powers. And how I remember this, guys, is I always kind of think a small thing is a fraction of a big thing. So that always reminds me to use the reciprocal. At the previous one, if we were going big to small, how I remember that is I always say, well, a big thing is a multiple of small things. So that's kind of a nice handy way to remember which you use, whether you use the reciprocal or just a multiple. So we're going up the list, we're going from small to big, centimeters to meters. So we get the reciprocal of the difference in powers. And now we have our conversion factor, guys. So that's what we were looking for here. 1 centimeter is 1/100 of a meter. And now we bring in the 240. So 240 centimeters is 2.4 meters. So like I said, some of them, guys, you might be able to do that in your head, but it's important to have a technique that will work. So now I'll describe the method. Ignore the number bit until the end. Establish the base relationship. This applies, guys, to all the problems we'll be looking at today. Always you need to figure what is being changed into what. What's the difference in powers? Absolute with no signs. Are we going from big to small? Are we heading down the list? Or are we going from small to big? Going up the list. So if we're going down the list, going from big to small, we multiply by the difference in powers. And if you're going the other way, it's the reciprocal, simply. If we're going from small to big, if we're heading up the list, multiply by the reciprocal of the difference in powers. And then this is just what I was saying, a big thing is a multiple of small things. This is how I always remember it. Or if I'm going a small to big, a small thing is a fraction of a big thing. That just helps me remember when I'm kind of doing these on the fly. Finally then, guys, bring in the number bit, multiply both sides by it, and simplify. So that coefficient shouldn't be used until the very end. Now, here's some problems for you guys to try. So maybe pause the video and give these a go. Try and follow that technique, guys. What's the difference in powers? Am I going from small to big? And you'll find it's quite a solid technique that'll kind of hold regardless of what prefixes we're changing into or out of. So now we look at the next problem type, converting units of area and volume. The technique is the same, just units of area are squared, units of volumes are cubed. And here's a typical problem. Convert 85 centimeters squared into millimeters squared. Now one thing, guys, to be careful of, this is 85 centimeters squared, so it's like 85 of these. It's not 85 centimeters to be squared, which would look like this, and it's a completely different thing because we'd be squaring the 85 as well. So just be aware of that difference, guys. There's no brackets around the number and the unit, so it's only the unit. It's 85 square centimeters. So just to be clear on that before we start. So first thing again, guys, we need to establish a base relationship. Again, like before, the 85 is left until the very end. And we need to establish a relationship. Well, 1 centimeter squared is how many millimeters squared? And it's not the same as if it was just 1 centimeter is 10 millimeters. We need to take the squared into effect. But we do start with that relationship. From here, guys, we can figure out 1 centimeter is 10 millimeters. So now if we're to figure out, well, what's 1 centimeter squared, we can either draw a wee box like this, or we can just square both sides. I personally prefer drawing the box, but it's a little bit more laborious. This method is quicker and it's very neat. The main thing though, guys, is remember, if we're squaring AB, both bits get squared. So the number gets squared and the unit gets squared. Now the same happens here. The 10 gets squared and the millimeters get squared. So now we just do square out the 10. So now, guys, we have our base relationship. And you'll find that's all the work goes into that part. And in any kind of an exam scenario, 80% of the marks at least would go for establishing that. 1 centimeter squared is 100 millimeters squared. And now we just multiply both sides by 85. And we get our answer there, 8,500 millimeters squared. Just be careful, guys, it's very common people just write 850 because they kind of just multiply, or they think, oh, there's 10 of these, just multiply by 10. It's not that straightforward. I hope the diagram kind of makes that clear. We look at another example. Convert 28,000 meters squared into kilometers squared. We just get our units up. So 1 kilometer is 1,000 meters. So then, guys, 1 meter, we're going from meters into kilometers. We use the reciprocal of 1,000. 1 meter is 1,000th of a kilometer. And now if we draw a little box, it would look like this. Or else, like I said, we could just square both sides. We now want to establish the relationship. Well, 1 meter is 1,000th of a kilometer, so 1 meter squared. We can square both sides. Again, 1 squared is just 1. And we get this for the right hand side. So 1 meter squared, remember, guys, 1 squared, we could square the top, square the bottom. So that gives us 1 and 6 zeros, 1 over a million on the bottom. And finally now, that's our relationship between meter squared and kilometer squared. And that's, again, guys, you can see that's where all the work is really done. Now we multiply both sides by 28,000. If you want, guys, write that number as a fraction, top by top, bottom by bottom. And then cancel. We get 28 over 1,000. Cancel 3 zeros. So our answer then is 0.028 kilometers squared. Now we just take a look at units of volume. Convert millimeter squared into centimeter squared. Well, first of all, we need to establish what's the relationship between millimeters and centimeters. Well, 1 centimeter is 10 millimeters. So 1 millimeter is 1/10 of a centimeter. If we were to turn that into a cubic shape, 1 cubic millimeter looks like this on the left. So it would look like that on the right. Alternatively, guys, again, that's quite a complicated drawing. We could just cube both sides. And that'll be so we cube both sides. And the cube will go in. 1 cubed is still 1. 1/10 to be cubed, cube the top, cube the bottom. And now we can multiply both sides by 2,200. And 2,200 millimeter squared is 2.2, sorry, millimeter cubed. That should be cubed. Is 2.2 centimeters cubed. So I hope that makes sense, guys. Again, they can be tricky, but as long as you just apply a kind of a solid technique, you'll find you'll usually arrive at the right answer. And these are not by any means easy, guys. You know, engineers and scientists, professionals still struggle with these. Like this is very tricky maths, but you've just got to be careful and you've got to be methodical. So again, guys, just a couple of problems. To have a wee go at and just to practice. Now there's more of these guys done on the video, so if you want to check the video on Moodle, you'll kind of find different problems being worked out, so that might help you if you're still kind of struggling, which is perfectly normal, by the way. So we'll push on, we look at the last technique, and this is converting flow rates and rates of change. This is where we have two unit conversions going on at the same time. So convert liters per hour, this is flow rate, liters per hour into milliliters per second. So really what's going on here, guys, is first of all, again, park the 36 until the very end. We need to establish this relationship. 1 liter an hour is what milliliters per second. And I have two little question marks here, guys, because it's just kind of let you know that there's two conversions going on. Liters into mils and hours into seconds. But luckily they kind of sit above each other or below each other. So we have the maths to deal with them. So this is really what we're looking at. Again, the 36, like I said, is waiting until the very end. Don't bring him in at the start. So liters into milliliters, guys. We need this for the top relationship. We're converting liters per hour into hours per second. Sorry, liters per hour into mils per second. So we need a conversion factor for the top, and we need a conversion factor for the bottom. So liters into mils, we can see the conversion factor is 1,000. Hours into seconds, again we're going with the conversion. So this, guys, is now our conversion factor. So liters into milliliters on top, multiply. Now again, you could stick a little multiply in here if you wanted. And now cancel as much as we can. The hundreds will cancel. And then 2 will go in. And we get 5/18. So 1 liter per hour is 5/18 mils. And leaving it as that fraction, guys, is actually the tidiest way. As soon as you try and get a decimal, you're going to have to start rounding up, and you will be introducing inaccuracies. As well, I'll always, nearly always, as much as I can, have designed the problem that cancellation will kind of occur quite easily. So don't be tempted to dive for the calculator. Leave it as a fraction and wait to see what happens at the end. So this, guys, again, that's where all the work in the problem goes, is establishing the base relationship. Now we can figure out for any quantity, any amount of liters per hour we can convert into mils per second. Just simply multiply both sides by our coefficient, which is 36 in this case. And now, guys, we'll see the 18 will go in there once, 18 will go in there twice. So 36 liters per hour is the same as 10 milliliters per second. We look at a similar type 1. convert 20 meters a second into miles per hour, mph. So here's our conversion factors. So first we need to establish the base relationship. 1 meter a second is how many miles per hour? And again, I'm trying to let you know there's two conversions going on. One on the top, meters into miles, and one on the bottom, seconds into hours. So here we have meters into miles on the top. So that conversion, guys, we need to go from meters into miles. We're going against the given conversion rate. So 1 meter is 1/1600th of a mile. So that's what goes on the top line. Similarly then, guys, 1 second is 1/3600th of an hour. Now remember our fractions. Flip the lower fraction, multiply. So he'll look like this. And then we'll have 1/1600, top by top, bottom by bottom. And then, guys, cancel divide by hundreds. And then divide by 4 will go into the top 9 times. 4 will go into the bottom. And that's our conversion factor then. All of that work, guys, that 9/4 is the conversion factor. 1 meter per second is 9/4 miles per hour. And once again, that's where all the work lies, is establishing that. And that, guys, should be your goal always at the start, because people, I see it all the time, people start these problems and they don't really know where they're going. And then they kind of just get lost and the 20 gets thrown in. And once we're here now, guys, it's easy. Multiply both sides by 20. Again, cancellation. And we end up with 20 meters per second is 45 miles an hour. So we look at it one more. This is a tricky one. 3.3 pounds per square inch into kilograms per meter squared. So here's the units we need. Again, these are always given to you. So we need to go from pounds per square inch into kilograms per meter squared. And again, guys, there's two conversions. Pounds into kilograms and inch squared into meter squared. So we need the kind of skills we developed in the second type of problem. So our main problem, guys, again, we have to set this up. One conversion factor on the top, pounds into kilograms, and another conversion factor on the bottom, inch squared into meter squared. Well, the first thing we need to do there, guys, is go, well, what's 1 inch in terms of meters? And then we can start to figure things out from there. So on the top, guys, I hope you'll agree, we're going from pounds into kilos. So we're going against the conversion factor, so we use the reciprocal. Now, guys, we're going 1 inch from here. Again, we're going from inches to meters. We're going against the conversion factor, so we use the reciprocal. 1 inch is 1/40 meters. And now we square both sides. So 1 squared, so 1 inch squared. Again, I'll make that look like a 1. Is equal to, well, we square this bit and we square the meter squared. I'll get rid of that there so it looks a bit better. So we'll have 1/40 squared, 4 by 4 is 16 with 2 zeros, meter squared. So that's our conversion factor for the bottom. 1 inch squared is 1/1600th of a meter squared. Flip the lower fraction and multiply. And finally, guys, I cancelled here. I was wondering whether I should or not, but I did just because it looked fairly straightforward. So that's my conversion factor then, guys. 1 pound per square inch is 800 divided by 1.1 kilograms per meter squared. And again, guys, don't be tempted to get the calculator because you're going to be bringing in rounding errors straight away. 3.3, multiply both sides by 3.3. 1.1 will go in there once, it'll go in there 3 times. So we have 3 by 800. So 3.3 pounds per square inch is 2,400 kilograms per meter squared. So that's quite a complicated conversion, guys. And if you feel fairly confident doing that, then you're more than where we would like you to be, because this is a very difficult skill set to kind of obtain. So please don't think it's easy, guys. It's not. And if you do find yourself struggling, you're with the vast majority of scientists and engineers who have passed before you. So thanks very much, guys, for listening. That kind of finishes us up, except for the fun bit at the end. So just question 14.3, the last question. Have a go at each of these. So, okay, guys, that finishes us up. I want to kind of get the video to stop now. So thanks very much for listening again, guys, and we'll chat to you for lecture 15.